So let's talk about film growth. I liken our thin films, particularly in the box coater world, to having like a tea kettle here, and I evaporate the water, and I have a substrate here, maybe a plate, and hold it in the steam, and I get a deposition on that surface. So if the plate's at room temperature, I'll probably get water droplets on that. If the plate's below freezing, I might get the water droplets on there, but then it freezes and I actually have ice, like freezing rain on it. And if the plate's much cooler than freezing, I'm probably going to get frost. And the coatings that I'm used to doing, and most of us are, fall into this kind of thing and have this kind of behavior. Here's some simulations, computer simulations by Karl-Heinz Müller in Australia, where he's doing this at 77 centigrade and this at 147 centigrade, and he's depositing nickel. And so at this lower temperature, the nickel deposits this way, and at a higher temperature, it deposits more densely. So one example is, for example, I deposit magnesium fluoride on glass. If I do that at room temperature, take it out of the chamber, I can wipe it off with my finger. It has no adhesion, no hardness. If I put it down at 300 degrees centigrade, I can take it out and do an eraser rub test, 50 strokes or something like that, no problem. So this is an illustration of what's going on there. As I describe it, when a molecule evaporates, an atom evaporates, we'll say magnesium fluoride, the energy it has as it leaves that surface is on the order of 1/10 of an electron volt. That's like it just goes, okay, if you insist. And it meanders up to the substrate, and it bumps its head on the substrate and sticks. And it can't move anymore, it's lost all its energy. On the other hand, if the substrate was warm, and it gets up there, it at least has the energy it came with. So it can kind of move around a little bit. And if there's another magnesium fluoride next to it, it can kind of nestle in closer and snuggle up. And then it loses its energy and it's stuck there. So the temperature of the substrate is important, which is what I showed you in the previous slide. And that's what this is illustrating. So the evaporating energy is nil. And I'm going to lose it very quickly depending on the temperature of the substrate. And we'll later talk about ion assist when I'm starting to put energy into all of this. And that's the modern technology that's changed our life and what we can do.